right. Hi, everybody. I'm planning to use pretty much all 50 minutes, so I'm going to get started right away. I know that there are a lot of really exciting talks happening at Devoxx today, and if you have already seen the serverless deep dive, a lot of what I'm going to cover is fairly similar to that. So I will not be offended if you get up and leave right now and go to something else that you would like to see, and then you can watch the recording of this later. If you'd like to stay, I promise I will make you laugh. Even if you are Finnish, and I'm told that Finnish people don't laugh. Also Belgian people, apparently. So I'm American, sorry about that, nothing I can do. My name is Randall, I'm a software engineer and technical evangelist at AWS. I don't really know what a technical evangelist does, but I do know what a software engineer does. And somehow I get paid to write code and travel around the world. It's a great job, strongly recommend it. We are hiring. Ding. You can tweet at me at Randall Hunt. Definitely do that, unless you think this presentation sucks, and then don't do that. But if you think it's awesome, tweet, because my boss will see those tweets, and then I'll probably get paid more, maybe. So, what are we going to cover today? Today, we are going to cover what serverless is. We're going to cover what microservices are. We're going to do a very quick vocab and service overview. These are sort of like your Legos, your building blocks for the serverless applications and microservices that you're planning to build. Am I speaking too quickly? Okay. I just had a ton of caffeine, and I don't drink caffeine normally. That jet lag is real, and I just, whew. So then we're going to talk about continuous integration and continuous deployment, delivery, that kind of things with serverless microservices. And then bonus section is going to be debugging and instrumenting production microservices. And there's a demo or two in between there. For a quick kind of level checking, who here has used AWS Lambda? Great. So for the purposes of a video, that was 100% of the audience. Everybody here is an expert. There's no reason for me to do this talk, so I'm just going to go. All right. So it seems like some people have some general familiarity with Lambda. How about other functions as a service platforms, like any kind of functions as a service from any cloud provider, or even a local one, like OpenWhisk? Yeah? So some general familiarity. What about some of the other services, like API Gateway? Have people used that? Okay. And I realize this is a Java conference, so how many people use Python? Okay, great. I'm going to not talk too much about Java. I might talk a little bit. So let's take a step back here and look at the evolution of computing. And I'm sorry if you've seen these slides before, but they're really pretty and well animated, so I'm going to use them again. First, we start out, we have these physical servers and data centers, low utilization. Every company is building their own data center. It costs a lot of money, not the greatest in the world. Then we start deploying virtual servers on hypervisors in various data centers. And hypervisors like Zen or QEMU or KVM or VirtualBox or Virtual VMware, whatever they're called. They're a great AWS partner. Probably going to get fired for that. And we get higher utilization. We are able to deploy a little bit better. Things get better. And then we have virtual servers in the cloud. So each stage of this evolution provided a key improvement. Virtualization improved utilization, introduced separation from the physical hardware, making applications more resilient and more hardware independent. It gave us more availability and resistance and resilience against failure. It improved our uptime, our disaster recovery, all that good stuff. And then we move to the cloud, we start trading our capital expenditure for operational expenditure, which allows vaster scales of operations for peak loads. This is the elastic argument. We start moving into this realm where our services can move up and down with the curve of the demand. Amazon's pretty darn good at this. We've been doing it for a while, and we wanted to kind of bring that model to everybody else. So that's the way it works out. But you still have to manage a lot. You still have to administer everything from the server up, so the virtual server up. So you're still responsible for patching the OS, for identity and access management and SSH keys or whatever on those servers. You have to make sure you're controlling that access. You still have to plan capacity in some way. And you're also kind of dealing with availability within various regions and stuff like that. So not an ideal situation, but much better than it was before. But we thought we could solve a lot of these problems. And this is where serverless comes in. Aren't these animations pretty? Yeah. I didn't make them. These are from Tim Wagner, who's kind of our general manager of serverless at Amazon Web Services. So there's no server that's easier to manage than no server. And the term serverless is kind of frequently derided for being not that great, because there are servers obviously running your code somewhere. It's just that they're not your servers. They're ours. And so we're covering that idle time for you. All these responsibilities go away. You don't have to worry about provisioning and utilization. You don't have to worry about fault tolerance and availability, or region availability and availability zones. You don't have to worry about scaling. And the operations and management side of things, where you make that argument whether or not that goes away, I've heard it on both sides. I'm of the opinion that you still have to worry about ops to a certain degree, but it's a different kind of ops. It's a different set of things that you're building and thinking about. And I'll talk a little bit about that later. It's also more secure. So you don't have to deal with OS level patches. You don't have to deal with SSHing into your Lambda functions, although you could if you wanted to. Don't do that. Every request is authorized with temporary IAM, identity and access management credentials, and your functions are typically ephemeral, short-lived, meaning they don't need to be given like this permanent access to very secure resources. So this brings us to this like spectrum of compute options that are available to us today. And even though this access is increasing to the right, just imagine it's actually getting smaller. I'm bad at slides. So the size of the deployable unit that we're dealing with within a virtual machine, that's like an infrastructure as a service. Then we get to a container that's like Docker or Hyper-V or something. And then we have an application, which is like a platform as a service. And then we have functions as a service on the far side, where the gross majority of the responsibility for running that infrastructure is on the cloud provider, and the code, like the business unit that you were trying to execute, is the only thing that you're responsible for. Is everybody bored to tears yet? Should I skip to the demo? Okay, that was a resounding yes from the audience. Everybody's falling asleep. So in a typical AWS environment, this looks like Amazon EC2 for the virtual machine, ECS for kind of the containerization, something like Elastic Beanstalk for deploying your apps, and then for functions as a service, you have Lambda. And it's kind of like this best of all worlds. The size of the deployable unit is quite small. The provider, the cloud provider, is responsible for the gross majority of the management. So it changes how you deliver. It eliminates all of this operational complexity that you're used to dealing with. It increases your developer productivity because you're now focusing on a very small unit of execution, typically like a couple hundred lines of code that's doing one thing. Like most microservices are actually composed of mini nanoservices. I'm not going to start the term nanoservices. Please don't start that term because we already have microservices. There's no reason to go in nanoservices. You have these Lambda functions that are composing themselves into these larger microservices. And because they're only focusing on this one sort of execution, you have one developer who is now like hyper productive because they're able to go in and manipulate things without worrying too much about downstream maintenance. And it speeds up your ability to get stuff working. And it's kind of this virtuous cycle. Everything's running, everything's making your business run faster. So that's serverless. Let's kind of pivot now to talk more about microservices. So I realize how many people here would consider themselves Java developers? Surprisingly, for the live streaming audience, no one raised their hand. It was just completely empty. Nobody here is a Java developer at all. So do you guys remember back in the day before we had Spring, before we had all of this like just-in-time dependency injection stuff? We basically had these giant jar files or these giant class objects that we were deploying. And this was like the monolith idea. And then over time, I think Java was probably the first kind of language that started breaking things out into microservices back when we had SOAP, like XML. And then we kind of move into this functions as a service realm. So if we look at this, splitting monolithic applications into microservices 10 years ago was basically transferring these XML blocks between different services, typically on the same network, not normally across different businesses. It was mostly within our network, we are going to have this SOAP API that we use to call stuff. And there's this very famous memo that went around Amazon. I think it was Jeff Bezos that sent it out, and it's like, by Friday, every service can only communicate over an API, and if you don't do this, you will be fired. Something along those lines. And people think that you'll be fired part is a joke, but that just means you didn't work at Amazon. It's also a joke. Definitely going to get fired for this talk. So 5 years ago, we started moving into this idea of JSON as our transport medium. But it wasn't just JSON, right? We started enabling remote procedure calls. Google came out with a protobuf. So we started enabling all of these like really fast binary encodings that we could transfer things over the network. And it basically built this distributed microservices architecture, which is what we're looking at now. And that grew in complexity, and all of these data started flying around. And maybe when you look into the cloud section of things, these individual nodes may not actually be Lambda functions. They could be individual services, individual sets of services within your application infrastructure. And then Lambda is what's gluing them together. Lambda is kind of holding everything together, and it's like the Force. You know, anybody watch Star Wars? Okay. So if we think about what our standard building blocks are, like our Legos for building our services, we have API Gateway, we have SQS, DynamoDB, and I highlight DynamoDB here, but it's not like that's the only data store you can use. There's a lot of like stuff out there that you can communicate to over Lambda. You have Kinesis, you have SNS, you have S3, and I'll talk a little bit more about each of these in a moment, but you have all of this business logic that you have to use to glue your stuff together. And that business logic is essentially just Lambda functions. And what will happen is these ephemeral functions will only be invoked when they need to be. So they're not sitting around idle all the time like your old servers would. They're only being invoked when some event is triggering them. This is a very powerful concept. It allows you to start thinking about infrastructure in a completely different paradigm. And it costs nothing to run these things when they're not running. So this is just what our building blocks are for our serverless applications. And in typical Amazon fashion, we have put our name in front of literally everything. So I'm going to read this off. So we have AWS Lambda. That's kind of your core execution medium. You can think about that as like copying and pasting some code into a function. You have S3. That's kind of like your key blob storage. Some people call it a key value, but it's really just key blob. And blob is like a real thing. Blob is like a binary object. Then you have DynamoDB. But you don't just have DynamoDB within your data tier. You could also have RDS. You could communicate with Postgres, MySQL, Oracle if you really wanted to. You do you. API Gateway is kind of our means of invoking things over HTTPS. We have SQS. We have SNS for our messaging and notifications. We have Kinesis for like our clickstream data or any other kind of streaming data that we want to ingest and perform events or perform actions on. And then step functions. Does anybody use step functions? Again, 100% of the audience. There was like one person that raised their hand. Thank you. So step functions are really, really powerful. And I encourage you all to check them out if you haven't already, because they allow you to orchestrate complex state machines using Lambda functions. And it's just a JSON document that specifies a state machine. And you can say, hey, retry this every 1 second. Or I want you to wait for manual input on this step. It's very cool stuff. And then I'm really excited, if we have time, I'm going to launch into a discussion about AWS X-Ray. Excuse me. Again, do not down 20 liters of coffee right before a talk. Pro tip. We're going to have AWS X-Ray, which allows you to instrument and visualize that service map that I was showing you earlier. And then, really, really cool, I won't have time to talk about it today, but it's something that you should research, this idea of edge computing. And this is the idea that you can have a Lambda function that runs the same in a data center, the same on an IoT device, or the same at a POP location, like a point of presence, like a CloudFront point of presence, like in Antwerp or Brussels or Paris. It doesn't necessarily need to be running in AWS region. So here are kind of the common use cases for AWS Lambda. You have web applications and backends, and that's what I spend the gross majority of my time on, is working with customers to build those. But that's actually not where most Lambda functions get deployed. A huge number of data processing pipelines end up using Lambda. Chatbots use Lambda. Amazon Alexa skills use Lambda. Does anybody use Alexa? I mainly use it to prank my parents, but it's also good for other things. And these are all powered by Lambda functions. And then on the other side, you have IT automation, which is Joe Schmo launches a new instance, and he opens all the ports. And that instance also has the ability to communicate with some of my other instances I want Lambda to come in with a config rule and shut that down because that's violating my policy of security controls. And you can do all of this very easily with Lambda functions. And I see a ton of stuff around that. Are you guys ready for a demo? No? You want me to keep talking? I saw various shrugs in the audience. Okay, so I'm sure many of you have seen this before. We're going to launch right into it, though. Hopefully, I'm not going to show any secret stuff. Let me log out really fast because I'm not sure I'm in the right account. I really hope the internet is fast. Oh, no. So this is called 1.5 factors of authentication. That's the subject of my rejected PyCon talk, if anybody's interested in that. So what I'm going to do is I'm going to go into Lambda, and I have created a function already that's called where am I. Oops. Way too much coffee. And this is a very simple function. Does anybody use Foursquare? Okay, that was 100% of the audience. I really hope they go public one day. So Foursquare is this application that you use to check into venues. You could also use like Facebook to check into a venue, and you're saying, hey, I'm here. I'm going to write a little review about it, and you get points. And the best thing about it is if you travel around the world, those points you can get on a leaderboard and you can beat your friends. And there's no actual value to that. It just makes you feel vastly superior for no reason at all, which describes a lot of computer science. So I have this function, and all it does is it calls out to the Foursquare API, and it gets my current location. Now, I can invoke this function. Oops. AWS Lambda invoke. Everybody can see that sort of, right? And I'll just go vim output, and it says, I was last at the Radisson Blu Astrid Hotel, which is not where I am right now. So all I'm going to do is I'm just going to check in on Foursquare to a different place very quickly. Devoxx, Belgium 2017. And then if I invoke it again, it should say, okay, great, Devoxx, Belgium 2017. But the main reason that I built this was actually because I travel a lot, and my mother asks a lot of questions about where I am, and I thought it would be great to like automate those responses. Now, I'm sure many of you have parents as well. Most humans do. And I realize we have Ox, who's not necessarily human, but we could say that he or she has parents as well. So what you can do with that Lambda function that I created right here is I confront this with an entire API. So I can go to API Gateway, and I can build. I don't have a ton of time, so I might move pretty quickly here. So I can build an API, and I can create an endpoint here, and I'll just say create method get. And this get method is going to invoke a Lambda function in US East 1, and that Lambda function is going to be where Randall at. And then we're going to deploy. And like any real developer, we deploy to prod. And this is the little thing that I get. So I can take this and I can do like curl, oops, and it works. So I get my location, all this other stuff. However, you know, my mom, she's a pretty clever lady. I'm very confident that she could master curl and be able to get those locations and things. But my grandmother, not so great at curl. Like, she could craft a TCP packet from scratch, right? Like, she'd sit there and she'd write it, and then she'd send it in the mail, and I'd get it, and then I'd send it to API Gateway, transcode it. But as far as like getting on the computer and typing it out, she's not into that. So what we do to enable her to get that information, that same information, is taking the same Lambda function, but with another transform, another Lambda function in front of it that's going to transform that data. We can go in and we can say, hey, I have this Lex robot, and this Lex robot is going to enable somebody to, Lex, by the way, is a chatbot service, it's gonna be like, where the hell are you? And it'll say, Randall was last at Devoxx Belgium 2 minutes ago, which is really interesting. It's like the same Lambda function, I'm just putting another Lambda function in front of it to transform it. So that's kind of like our microservices architectures. We have one Lambda function that's being the glue, another Lambda function that's fetching the data, storing it in Dynamo, all that good stuff. But that's not very useful. So my grandmother being on Facebook, I created a Facebook bot that pretends to be me. And then it's just like, where are you at? I was last in Tokyo, apparently. I was like, Randall was there. And I didn't have to do anything to enable this, right? Like, it's just, I go in and I set up like Twilio, I set up Slack, I set up Facebook, and I'm not having to like write any code or authentication stuff to get this working. I'm just like, here are my API keys, please work. But what's really, really cool is you can go further because Lex is not just for text, it's also for voice. So I have we have this service called Amazon Connect, and it's for building call centers, virtual call centers, and it's typically used by airlines or like credit card companies to make you wait on hold forever. But it can also be used to filter calls from your family and then respond to them if they press certain buttons. So if we look at one of these contact flows here, I have a very simple flow, and it's just like, hey, set the voice. We should probably make this a different voice so that it sounds like me. There we go. So we'll save this, we'll publish. And I can invoke the same Lexbot that I already had, the same Lambda function, all the same stuff. I'm not having to change anything, and it'll work. So we could test this by calling, theoretically.
Hey, Devoxx. I can tell you where someone is from their last Foursquare check-in if you ask me.
Where is Randall?
Randall was last at Devoxx Belgium 2017, 4 minutes ago.
Yeah, so it works pretty well. That's about the time that I got here, judging from the excited people in the audience. And this is, keep in mind, this is all one Lambda function that's just going and storing some state in Dynamo, running on some cron job or running on some event. Like there could be a webhook that's listening on the Foursquare side that's going and updating the location. And you could do this for multiple users. It's not like it's limited to just me. For instance, I could track my father, who is basically always at home. So that's kind of to inspire you that you're not limited to like these stale, boring CRUD apps. Although you can build that very easily with Lambda, you can also do tons of other stuff. And if you guys are building something really cool, or if you have questions later, I can throw these little socks at you. And I'll talk about these socks in just a second. That's not a proxy joke. Okay, so I want to talk a little bit about understanding how you can continuously integrate and deliver these Lambda functions. And also these whole applications, like the ones that I was just describing. So continuous integration basically covers, I've committed some patch, I want it to be pulled down, I want it to be built, and then continuous delivery covers everything after that, the testing, the deployment, maybe the rollout in a weighted way, stuff like that. And that little gate there is like, imagine a human is sitting there being the final arbiter. Don't do that in real life. So if you think about Amazon.com, the retail site, and all the various web services that we use at Amazon.com, we actually deploy like multiple times per minute every day. So we are constantly deploying new stuff across all of our web services. And this is enabled through these kind of pipelines. So when you talk about serverless applications, Lambda functions are your typical unit of deployment. But most microservices are comprised of or composed of. I actually don't know which word you're supposed to use there. English is really hard. They're comprised of multiple Lambda functions and also API gateways and typically other AWS services as well. So the typical way that you deploy large swaths of infrastructure like that is through CloudFormation. CloudFormation is a service that we have where you specify in a YAML or JSON doc, hey, I want this stuff. Please give me this stuff. And Amazon says, okay, please blindly swipe your credit card and we will give you that stuff that you asked for. Again, laughing is allowed. So when you're building all of this stuff, you can bring your own ID. Oh, this is a great thing. Who here uses Emacs? Wow, nobody. Okay, watch this, watch this. Who here uses Vim? Woo! That was 100% of the audience. What about Eclipse? Okay. And IntelliJ? Whoa, okay. IntelliJ is the shit. Like, I love that stuff. I use it like every day. Vim is kind of like where my head's at most of the time, but IntelliJ, pretty good. So you can bring your own IDE, and Eclipse and IntelliJ and even Visual Studio Code. Anybody using that? Yeah, it's a good editor. I like it. I don't know how they made an Electron app fast, because it's JavaScript. JavaScript is just terrible. Honestly, I think JavaScript is basically mass psychosis at this point. Like we have like Stockholm syndrome. So that's a rant that I can get on another time if you guys are interested. These photographs are making me so nervous. Oh God. So you can bring your own IDE to the situation, and we have plugins for most of these IDEs where you can go in and say, hey, start building my stuff. I've saved this. I want you to run some local test, all that good stuff. In Java, this is way more developed than it is in other languages, just because you guys are good at things, whereas most other languages are like, LOL, I can program. And then we have whatever version control we want. We could have GitHub, we could have code commit, we could have Bitbucket, whatever. We can have hooks on this whenever we submit a patch, we want to start doing stuff. And we have building tools, testing tools, deploy tools, infrastructure management tools we don't need quite as much. Then we have lifecycle automation tools. And code build is kind of at the center of this. Code build is what's going to take some Docker container that you have for building your information and go and create an artifact that you can deploy. And I'll talk a little bit about what those artifacts could be. But it also integrates with Code Pipeline, which is another service. I'm going to stop saying Amazon in front of every service name because I'm pretty sure you guys have figured out at this point that I'm basically a corporate shill who just says Amazon like every 5 minutes. Yeah? I'm glad you're laughing. Let's keep it up. So this is an example of a build spec. So a build spec YAML, the best part about this file, by the way, if you lend me your ears for a moment, is saying saml.yaml. Just say that 10 times fast, see what happens. SAML.yaml, SAML.yaml, SAML. Yeah. You can build all of these different phases. So let's say we start with our, like, let's install some prerequisite phases, then let's like lint everything, let's build and test stuff, and then let's package everything up into some sort of artifact, which is this like post SAML.yaml file, and deploy it. And that's all we need to do to start deploying things with code build. What do deployment packages look like? We'll ignore Node.js and only talk about Python, Java, and real languages. So within Java, you basically post a zip or a jar. You can use Gradle, you can use Maven, you can use whatever you want to kind of compose these functions, these services very easily. It's really, really straightforward. I'm sure you guys have done stuff like this before. All your libraries, they go in lib. Everything else kind of goes at the root with whatever package name. Very straightforward. You can also use C#. No comment on that. And then we have Code Pipeline, and what Code Pipeline enables is this kind of good stuff, where you can say, I have my application, I'm getting a commit, and then I want to, oh, sorry, I should do it this way. I have my application, I've got a commit coming in, I want to build, and then I want to do some testing. I want to run like various integration tests, various unit tests. Then I want to deploy it to one environment, do some stuff. Then I have a manual approval in there where I'm saying, okay, I want you, oh, and we can do some like performance regression testing with RunScope. And then I want to do, a human has to sign off on this, and then we deploy to prod. What most of mine look like is everything from testing and staging is gone, and it's just this section, like immediately deploy to prod. I don't recommend that in real life, though. If you don't feel like setting all of this stuff up by default, we have a service called Codestar, which will automatically provision all of this stuff for you. It's very pretty. It uses a lot of S3 buckets, though, and I keep hitting my S3 bucket limit, and I keep having to call my boss and be like, hey, can you fast track this ticket so that I can get more S3 buckets for a demo today? Or you and you'll notice that this is not my account. This is Chris Munn's account, and I'll talk a little bit about him in just a second. So the serverless application model is kind of what you use to package all of this stuff. And aside from having a really cute mascot, It's also a super useful paradigm for thinking about serverless applications. That's why it's called the serverless application model. And it's essentially a transform on CloudFormation, and it allows you to very quickly specify complex applications with just a little bit of YAML. And this is what it looks like. So I have an API, and this is a function, and I want it to pull that function from here. I want it to use Node.js because I hate myself. And then I have this IAM policy that it'll use, which is DynamoDB read-only access, and it's going to go and basically read everything coming in, and I'll take get method, I'll take post, whatever. I just want it to work. And then I have a table that I'm creating, which is just a simple DynamoDB table. So these SAML files can basically be parsed into this kind of cool infrastructure setup here. This is generated by the CloudFormation console. It's very pretty. And you can add little annotations to put everything right on top of each other to make it like a video game for the people who are trying to spin your stuff up. And then if you want to test all of the same stuff locally, it's really easy to take an existing SAM file and just run it locally. Because we have this tool called SAM Local, which will build a bunch of Docker containers and stuff that'll run everything for you. This is Visual Studio Code, which I am falling more and more in love with the more I use it, which is not something I thought I would say about a Microsoft product. But it is really good. So very easy. We can add something on here. I don't have a ton of time, so I'm going to skip the rest of it, but you can imagine how this works. Like, we're basically deploying good stuff. Very few of those slides were mine. They're actually from somebody called Chris Muntz, who also works at AWS, and he's kind of the head honcho for serverless there. And what he's going to do later today in this exact room at 4:40 is he's going to explain things in vastly more detail and vastly better than what I have done. And he will do less insane demos. There are a ton of community frameworks that you can use to do all of this stuff. So you're not limited to SAM. I think SAM is like a really good way of deploying things. But there are other ways. So if you write Python, there's Zappa, there's Chalice. If you write anything else, there's Serverless, there's Apex. There are all kinds of different community frameworks. And there's actually a GitHub page called awesome-serverless that kind of collects all of this stuff. And you can go look and see what best suits your needs. Okay, jumping around for a moment here. Everybody caught up? Feeling good? This is my favorite part. So we have this really cool service called X-Ray. And what X-Ray does is it allows you to dive deep on exactly what is happening in your code at any point in time, exactly what is happening across multiple services at any point in time. So have any of you guys dealt with distributed tracing before in the audience? No one raised their hand. Just teasing. A lot of people raised their hand. And what kind of tools were available to you at the time? Did you have to build something yourself? Mostly? grep. Okay, so SSH, cluster SSH, grep across all my log files, and then typically people would probably use like Logstash and Elasticsearch for that, but grep works too. Oh, Java developers, I forgot. You guys have been around for a while. See, I don't remember those days because I was really busy playing RuneScape, and that was my introduction to Java, was hacking RuneScape, which is a Java video game. If anybody wants to talk about that, I can talk about, I think the statute of limitations on the Jagex lawsuit has like finally run out, so I can finally talk about how to hack RuneScape. That was my first exposure to Java. Somebody tweeted about that, so I should stop talking. So let's talk about X-Ray. What X-Ray allows you to do is I can just add a very simple library into my application, and I can start tracing every request to every AWS SDK. I can start tracing all of the requests to various endpoints within my microservices. And there's a company called Skyscanner that is based in London. Does anybody use Skyscanner to look for flights? There's 100% of the audience. You guys are doing great, Skyscanner. Keep it up. And what you can do is you can actually see what your code is doing across data at any point in time. And I'll show you kind of how that works. And we have SDKs available for Java, .NET, Python, Go, Node.js. And you can add all kinds of filters that will capture various data for kind of querying and figuring out what went wrong. So let's say you have a user that's reporting a 500 error, right? And that 500 error, you can see it in your logs, but the logs are not enough to determine what exactly is going wrong. So you dive deep into the instrumentation. You go and you can look up by that user's name when they invoke that call. You can trace using the information they submitted, the payload they submitted, all the way through your various microservices, through your load balancers, through everything, and find what actually went wrong where. And this is enabled through a daemon that runs on your instances or on the Lambda function that you're invoking. If it's running on a Lambda function, full disclosure, it does take a very modest amount of your memory. So let's say you have 128 megabyte. Oh, this is Java. Let's say you have a 512 megabyte function that you've deployed, and you have X-ray active tracing turned on that function. It will take like 2% of that memory. So something to keep in mind performance-wise. I have deployed this to like multiple production services. Again, not in Java though, and I have not experienced any performance impact at all. So I have been told that there is a performance impact, but I have yet to like see it. So keep that in mind. And what it does, this daemon, is it receives information about what's happening over UDP, buffers it, then sends it off to the X-ray service. So we have these kind of core concepts within X-ray. A trace is this end-to-end kind of ability to see where everything is running, and it's got a trace ID. We have segments, and segments are portions of the trace ID. They can either be defined by you, or they can be defined by the services that you're invoking. We have subsegments, and those are typically defined by you within your code. You're saying, okay, now I'm setting a cache key, or I'm removing a cache key, or I'm invalidating some state. Annotations are kind of data that you can put into traces that allow you to filter on them later. They're like things that you can be indexed on. Whereas metadata is just useful business information, but you can't actually query or search by it. Then we have errors, and errors are sort of this stack trace that's kind of normalized across all languages and across all kind of invocations of services. So you can dive deep on the individual stack traces. This is what a service graph looks like. I forget what orange means, but red is an error. I think orange is like a 400 and red is like a 500. And then purple is like a throttled. Purple is, hey, back off for a second. So we have this kind of front-end EC2 instance that's calling out to another EC2 instance that's calling out to SNS, that's calling out to DynamoDB. And you can see we're getting throttled a little bit here. So the first thing that comes to mind is, oh, hey, maybe I should up my capacity in my DynamoDB instance. It's not really a problem anymore now that we have auto-scaling on DynamoDB, but something to keep in mind. And then we can look at individual traces. We can dive deep and we can say, okay, these are the traces that I have. It's 4.9 seconds ago. I got a 409, and I'm not sure what went wrong. So let me dive deep on that 409. Did that work? I have the same slide twice, I guess. Sorry. And I can also query. I can say, okay, I want to only look at services like DynamoDB, or I only want to look at services like Lambda. And I can see, okay, I'm getting a couple 404s. Otherwise, I'm getting good stuff. I can continue to dive deep. I can add filters. So this URL, this remote signup URL, is the one that I want to look at. I have this latency, and then I can kind of look at one of these individual traces, and it says, okay, this took 13 seconds. There was some error somewhere, and when I look at this error, this is what I see. The conditional request failed. So that means, if I can parse the JavaScript here, which I'm sorry, I wouldn't make anybody do that, but we'll do it for the purposes of this presentation. Essentially, I was trying to set something that was already there, and so my condition preventing that from happening was invalid. So that's everything that I have. I can show you X-ray if you want, or we can move on to Q&A. This is me, Randall. You can tweet me any question you want. You can email me. I'll put my email up now. But definitely rate the session and give it like all 5 stars. Or like 1 star and leave like a comment. What a corporate shill. I'd be okay with that. So this is my email. You can email me and I will give you an AWS credit code if you want. That offer is valid for 24 hours. It's not a ton of credit, but if you tell me like I want to build something and I don't want to pay for it, I will happily give you that stuff. And we have exactly 10 minutes left, so I will answer questions. Anybody who asks a question, I will throw you a pair of these really cute socks. So bring it. Everybody's raising their hand right now. So for those of you on the live stream or watching this later, I'm really sorry. I just won't be able to take your questions, but tweet at me. Any questions? Yes. Which language is the best for Lambda functions? Definitely Python, but everyone else will disagree with me on that. The reason I say Python is because Python is the best language, period. And I realize I just made a ton of enemies, I'm sorry. But honestly, you can run any language pretty easily. You're not limited with C# or Java or anything like that. It's really straightforward to like build a deployment package and go and test things. The gross majority of the things that I write are written in Python, but I've also got a bunch of Java functions deployed. I'm a millennial, so I take a lot of selfies. And I have a Java function that calls out to recognition and renders all my selfies. So I can show you really fast. And the question was, which language is best? In case of Java, what do you deploy? So I will show you. If we look back at this slide, with Java, what you deploy is a zip file or a jar file, which are really the same thing, with very mild differences. And you can deploy things with just Maven, so you can do like Maven deploy, and it'll go out to Lambda, it'll talk to the API, it'll do all the stuff that you need it to do. We have all of that stuff in our documentation. It's really easy to pull down. Or you can deploy the stuff through just like uploading it, or just through the command line. Like however you want, you can deploy it. And then there was a question over here. The vendor lock-in. So the question is, what about vendor lock-in? And so the question is, with regards to vendor lock-in, how can I export all of my stuff to move to like another cloud provider or move to like OpenWhisk or something local? With regard to Lambda functions, you are mildly limited in that way, but it's still, keep in mind, just code. It's just like, I have this event that I'm getting, and then I'm parsing this event, and then I'm doing something. But with regard to the API gateway, we actually support Swagger. And Swagger is like this open API specification that you can move around to wherever you wanted. You can even run it locally. It'll auto-generate docs. It'll auto-generate a mobile SDK for you. So on the API gateway side, I don't really see any vendor lock-in at all. But I do see some like key differentiating factors in API gateway that are simply not available elsewhere, like built-in credential management, built-in throttling, all that good stuff. And if you find somewhere else that has that, I'd be happy to hear about it. Then, what does that .30 mean? Does that mean like I'm super out of time, or? Oh, half a minute. Oh, there we go. I never seen that format before. So with that in mind, yeah, there's vendor lock-in. If you're really worried about vendor lock-in, you're worrying about the wrong thing. And obviously I work for AWS, so I would say that. But you're going to have some form of vendor lock-in no matter what you do. And the question is that vendor lock-in preventing you from getting your business done? Like, what is your fear with vendor lock-in? You have vendor lock-in with the tools that you choose. If you choose Eclipse, like you have mild vendor lock-in with like the style checking that you use. If you choose Bigtable, you have mild vendor lock-in with like moving your data around to different places. You're going to have some form of that no matter what tools you go with. And it's up to you to kind of decide if this amount of vendor lock-in is tolerable for your application or if it's not. And I'm happy to help you with that decision because the decision is always try to use more AWS services. Again, corporate chill. You had a question, yes, sir. How long does a specific instance, so the question is, yeah, so if you guys were in the serverless deep dive yesterday, you would have heard about the static initializers. So in Java, for instance, you'd have a static initializer, you'd create your database pool there or your connection pool there, and it would reuse it across multiple invocations. We make no guarantees about when a container is warm or when that state will be reused. So you have to design around the fact that it could be created anew every time, but it in production will not be. Like I'll go ahead and say, in 99% of cases, it's not going to be new every time. Like subsequent invocations will reuse an existing container, but we don't really provide any insight into when that's happening or when that's not happening. So, yes, behind you, sorry. I'm trying to go in order. For a function? Yes. Faster. So we've recently made some pretty significant improvements in terms of like the cold start time for Java. The cold start time for every other language is negligible in my opinion, even if you're setting up some like complex connections and stuff. The pricing is the same like across each invocation. It's not like it changes day to day or anything. We have done price reductions over the years, and you can expect that we will continue that trend of price reductions as we are able to pass on savings to customers. One thing I will say is we just launched a pricing API, so you can now query the API and see what all of the different things are. If you want to subscribe to like price change notifications, there's an SNS topic that you can subscribe to. And I'm going to start throwing these out because I forgot that I was going to give these to people. Who asked the question first? You did? And then it was you. And then, do you want socks? Yeah? Oh, I'm sorry. They don't fly very well. They're not aerodynamic. 302. Move temporarily. Did you want socks? Okay. Did I miss anybody that asked a question? You did? Did you already ask a question? Oh, sorry, I don't. Are you? Okay. Again, the caffeine. And then there was a question up in the top there. Yes. I will actually say check out Chris Munn's talk for more information on that. I only have 2 minutes left, but that's Chris Munn's over there. You can either talk to him after this, or you can shoot me an email and I'll answer. I'm going to see if I can do this or not. Nope, not even close. My baseball career is over. Any other questions? I have like 1 minute left. Quick question, yeah. Integrating the what? The versioning system. Subversion, CVS, Perforce. Yeah, if you're still using CVS, please consider moving off of it. When I worked at SpaceX, we actually still use Subversion, so I feel your pain. But I would say Git is the future, and you can easily create, like SVN, Subversion, for instance, has webhooks. So you could have a webhook trigger something. You could even invoke locally on the SVN server. You could do the same on CVS. With Perforce, there are also webhooks. But the only time you're using Perforce is if you work at Google, right? So, they probably have their own thing. Yeah. And you can also use S3 as a source for code pipeline. And Chris will talk more about that. All right. Thank you guys so much for coming to my talk. Remember, you should definitely tweet and give me like all fives or just, punch me in the face. Thanks, guys.